Sending astronauts to Mars is a fine balance between keeping them alive and providing them with resources to be able to explore and understand the environment around them. Extravehicular activities will be incredibly important to not only the scientific discoveries on Mars, but also the overall well-being of our astronauts. So how will the astronauts be able to explore the land around it on Mars? Let's talk about that. One of the first things we need to discuss is the spacesuit that astronauts will wear on Mars. What's going to keep them alive when they're walking across the surface? Now, the first thing and most obvious is a pressurized system so that they're able to breathe. We also have to be able to control what temperature it is, whether that means having water cool throughout the system or having heating in case the Martian environment gets too cold for them. We also have to look into radiation protection. How exactly do we restrict the radiation and keep them a little bit safer? Water does an okay job at this, however, there's better objects in terms of the materials that we can use. We also have to look into dust protection. Now, the dust on Mars is actually so small that it can get into mechanical functions. Therefore, we want to make sure that does not get into the suit and make an impact on the pressurized system. Now, NASA and a few other universities have been developing spacesuits that could potentially be used on Mars, such as the NDX-2, the Z-2, and the Biosuit. Now, one of the major limitations to designing these spacesuits is how exactly the material reacts to the high radiation environment on Mars. But the good news is, NASA is actually already thinking about this. On the upcoming 2020 rover, they plan to test 6 different materials using their SHERLOC experiment. Now, SHERLOC stands for Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals. And this experiment is actually going to use these different materials, all 6 of them, as a calibration method. Now, the experiment will primarily be looking at samples from Mars. However, over time, we'll be able to look back at these different calibration materials or the fabrics and see how the radiation environment has actually impacted them. And the data we get from this experiment will help us show what we need to develop our Martian spacesuits out of. Now, there have been a couple solutions to vent out CO2 rather than store it, because on the International Space Station, the spacesuits they use, they actually store the CO2. However, when we're in the Martian environment, if we can vent that out, it would not only save weight, but it would also make it a little bit simpler for the astronauts to be able to fix it in case something went wrong. Now, another major aspect is the weight of the spacesuit. People typically think that these things are incredibly massive and that it would drag you down. However, the Martian gravity is only 37 to 38% of that here on Earth. Therefore, the spacesuit would actually make you more massive or have a higher mass. However, because of the lower gravitational force, your weight could be even less than it is here on Earth. Now, another major announcement in terms of spacesuits over the last year is that SpaceX has announced their spacesuit. And now it has been tested into a vacuum. However, it's theorized that this spacesuit will primarily be used for launch and landing, and not necessarily what will actually be used on the surface. However, there hasn't been a lot of information about this, so there's still more to come. Now, another major way of being able to move across the Martian landscape is having a car or a rover that you could drive across the surface. Now, when we think about sending rovers to Mars, we have to think back about the rovers that we already have there, and it becomes somewhat of an issue. The rovers we have now only go about a football field in distance or 100 meters per day, which is much slower than walking distance, which means would it actually be of benefit? Now, before we answer that, what's the major problem behind having these wheels? So in order to understand why wheels don't work on Mars, we have to first understand the basic physics of how a wheel even works. So let's take a simple tire and a paved road here on Earth. When you spin the tire, what's happening at the contact point between the tire and the ground is it's creating friction. Similar to how if you were to glide across ice and slowly come to a stop, the ground is trying to slow you down and stop your motion. Therefore, the paved road is actually trying to stop the tire from rotating. However, due to Newton's laws and equals and opposite forces, the stopping of the tire actually causes it to move forward. And that also dictates how fast the wheel can actually accelerate or go up an incline or a hill. Now, this becomes a problem because when you take that force over a distributed area, you get a pressure. On Mars, it's thought that it can only withstand about 0.2 psi or 0.2 pounds per square inch of pressure. Therefore, we have a lot of issues with trying to roam across Mars with just wheels. For example, the Spirit rover got stuck in sand and that was the end of its mission. Now, it's not because of this issue that we'd be able to create lightweight rovers or the lunar exploration rover like the Apollo missions that would be able to go farther and not weigh that much, just because we would want to be able to explore a little bit further than what we would be able to do in a walking distance. It is also thought that we could have larger vehicles, maybe more massive vehicles that could be used for building a colony or moving large structures from one side to the other. This is important because if we were able to develop a gravel road or something that's a little bit stronger than the typical regolith, then we would be able to have something better for transportation. Now, another major talking point is whether or not these rovers or these exploration rovers would be pressurized. In the movie The Martian, the rover is actually pressurized, and this means that when you enter the rover, you take your spacesuit off and it's its own habitat. You can live within it, you could survive within it, it's heated, it's cooled, everything is perfect for your astronaut. And a non-pressurized design would be like the Apollo missions, having a buggy where you'd have to be able to control it when you're in your spacesuit, which could make it a little bit more challenging. Now, NASA has actually been working on their space exploration vehicle concept, which is basically a pressurized vehicle that astronauts could live in for up to 2 weeks. It goes around 10 kilometers per hour at max speeds, and the wheels can actually pivot in any direction, which would help them get unstuck if they were to get stuck in sand. However, the issue with this design is that it weighs 6,600 pounds, which is incredibly massive when we talk about sending something to Mars. Now, even though the weight is incredibly high, having a pressurized vehicle like that would be remarkable for exploration missions, just because going out for a few days would make it a lot easier to go hundreds of miles or hundreds of kilometers rather than just being restricted to maybe 10 kilometers to within your landing site. So it's thought that pressurized vehicles would probably come eventually when a colony was built on Mars, however, probably wouldn't be used for just a one mission trip. I think one of the most important things to remember when we send rovers with people to Mars is the fact that we are sending astronauts with them. Cars get stuck in sand all the time here on Earth, but people are able to get them out because of our ingenuity. The issue with rovers on Mars now is that if we get them stuck, we aren't there to help them out. Therefore, if we have a lightweight enough rover or a buggy for our astronauts to use, I almost guarantee that it won't get stuck. And if it does, we can provide a winch to help it get out. So in the next episode, we're going to look at NASA's timeline. What missions do they have planned that are going to the Red Planet? And what should we expect in terms of the first manned missions to Mars? Thank you for watching, and I hope to see you in the next one.